beginning with section 10.2 on logarithms. See if we can actually get the board going here.
I have to sharpen my pencil. Sorry.
Okay, remind me, I can't see past the word logarithm, so don't write under that heading over there. Okay, the first thing is, what are logarithms? Why are they used, and why do we need to know what they are? Logarithms are used in place of exponential expressions. And all the operations that we went over and tested on yesterday are the same type concepts that we're going to be applying when we are solving logarithmic equations and when we're evaluating logarithmic expressions. So we had to learn how to solve those exponential equations in order to do what we're about to do today. Okay? But before we can start, I want you to understand logarithms. Scientific measurements that are enormous in range are written as logarithms. The measure of sound. How fast is sound? The speed of light. The molecular size of an atom.
Those are written in scientific notation, right?
Okay? Which scientific notation is a form of a logarithm.
Dang.
Because it is an exponential expression. Okay? But the difference between a logarithm and scientific notation is simply a shifting. I know you drew that there for a purpose and I just erased it, sorry.
Don't worry.
Okay, don't write it again, I'm good. Scientific notation is simply moving a decimal point. Okay, it's dealing with multiples of 10. Either we're multiplying by multiples of 10 or dividing by multiples of 10. Logarithms deal with exponentially increasing numbers. So what's the difference? If I say 2 to the 5th power, I can't simply move a decimal point and it's 2,000. Now I'm taking a number and I'm multiplying it over and over and over and over. So that's the difference between scientific notation and logarithms. Okay. All right, before we can start working with them though, we have to understand what they are and what they represent. This past week and what we just tested on, we worked with exponential expressions such as this. 5 to the x power is equal to 25. And we were looking for a value of x that would make this statement true. Well, without working it out, we should be able to know by now that the value of x is 2. Because 5 squared is what gives us 25. Correct? Okay. I want us to identify the pieces of this exponential expression because they are also present in a logarithm. And we need to know where they are. Because once we look at it, if we understand what we're looking at, then it makes so much more sense. This is called the what? What did we call this all last week?
Base.
We called this number the base of the expression. It's also the base in a logarithmic expression, and we'll see where it's located. This is our exponent, and this is our solution, or our answer, right? When we raise 5 to an exponent, we get 25. So we have our base, we have our exponent, and we have our solution.
So if you raise the base to an exponent, you get a solution?
Yes. Okay. Now in a logarithmic expression, this would be written as such. Now we just said x was 2, right? So let's actually substitute that in as 2.
Wow.
Now if you look from an exponential expression, this was 2, converted down to a logarithm, the same 3 pieces of the puzzle are there. It's just written differently. This reads the log to the base of 5. Notice, it even says the base of 5. So it has identified what my base is. Of 25 is 2. In a log expression, this is your base, this is your exponent, and this is your solution.
Are we gonna have to turn the top one into this kind?
Yes, in fact, that's what we're about to start doing. We are going to take a logarithmic expression and we are going to turn it into an exponential expression. And then we're going to take exponential expressions and turn them into logarithmic expressions. But I want you to understand, we're not talking about two completely different things. We're talking about the same thing, just differently. For example, turn 1/2 into a decimal.
0.5.
Turn 0.5 into a fraction. 1/2. Both of those expressions represent the same value. It's just written differently. Logarithms and exponential expressions represent the same value. It's just two different ways to write them. Okay? Now, the things that we just tested on, we had to have a basis and know how to solve those before I could start talking about logarithms. So right now, we're simply going to take a few of these and we're going to convert them. We're going to identify what's the base, what's the exponent, what's the solution. All right, so let's start with in this expression, it reads log to the base of 8 of 1 is 0. If I'm going to turn this into an exponential expression, what is the base of that expression? 8. What is the exponent?
0.
And the solution is?
So that's 1 equals 1, which is all.
Is that true?
Yes.
Because anything raised to the 0 power is 1.
But you know it to the first power.
No, anything to the first power is itself. 8 to the first power means you have 1/8. You have 8. Okay?
Last year, our math teacher, she told us that 8 to the 0 was 1.
Well, very good, because 8 to the 0 is 1.
I mean, 8 to the 0 was 0.
Oh.
I was confused. Then my tutor told me it's not, so I'm like...
Yeah, that's not what it is. Okay, now let's look at something else. Now this may look a lot more difficult, but we just focus on what's the base, what's the exponent, what's the solution.
We're going to have to say if it's true or not.
All these are going to be true. We're not trying to fool you right now. We're just trying to get you to understand how to transfer it from one way to another, because we're going to start taking them and using them in equations. All right? So we need to be able to understand how to go back and forth. What's the base?
2 to the 4th equals...
To the negative fourth
-4.
equals,
16 to the negative 1.
no, just 1/16. Just write it like it is. The three numbers that show up in the original problem, they're going to show up exactly the same. Okay? We're not going to change them. 2 to the negative 4th. Doesn't that mean that I have to invert and make this whole number a fraction? So that's actually 1/2 to the 4th power, which is 1/16. All right, I'm going to put 3 of them up on the board, and I want you to convert it.
I like this list.
And then we're going to go the other way. All right, the first one is, write this logarithmic expression as an exponential expression. And I'm writing really big for the camera, so I'm not going to have room. So we'll just do these two.
You can write them underneath it.
Yeah, I could. Let's do it. Okay, so right now we're not trying to solve for anything. We're simply